Hi everyone, let's begin one more non-parametric test, that is McNemar test. So let me introduce this test. What is this test? Where we are going to apply this test? So McNemar test is a non-parametric test. It is a very popular test of non-parametric category when our data is non-parametric. Non-parametric data means we are talking about it's not normally distributed. And usually this test used on the paired nominal data, where it is the nominal data we had collected, and it is applicable on dichotomous data. Dichotomous data means where is the two categories of that data, like male and female, right? There is two categories, employed, unemployed, that is again a two category, right? And such kind of two categories if we have data. So this is known as dichotomous data. It is applied to 2 by 2 contingency table with matched pair of subjects. Means there is the pairing of the data, pre and post, right? Suppose we have some students pre-workshop marks, and after conducting a workshop, then we had collected these marks. So this is known as paired data, right? So, but this data we had collected, the nominal data, right? Then we are going to apply McNemar test. Otherwise, if it is continuous data and that is normally distributed, so we are going to apply t-test, pair t-test, right? Or we can call it dependent t-test. So this one is it follows chi-square distribution to find out whether row and columns marginal frequencies are same or not, right? Then here is, we have taken total how many 45 students marks, and that is pre-marks and post-marks, means pre-workshop marks and post-workshop marks. One, we had defined for those students, those have scored more than 50% marks, and two, we have assigned to those have scored less than 50% marks. This is already defined in our software. And hypothesis we had created, there is no significant improvement in the marks of these students, right? There is no distribution. Distribution is same. So this is the, we can call it output. This one is the output we had collected through SPSS analysis. These are my outputs of SPSS. And this one is the chi-square test, and p-value, it is less than 0.05, right? So this is my interpretation. If the significant value is greater than 0.05, then fail to reject null hypothesis. If the significant value is less than 0.05, then reject null hypothesis. So in this case, because p-value, this is less than 0.05, so we will fail to reject null hypothesis. And in that way, right, this is our null hypothesis. The distribution of different value across pre and post are equally distributed, right? Equally. So there is, we would apply in Jamovi, and we will open this file, browse this file, and McNemar test. This one is my file. I have here only McNemar test.sav, right? This is my SPSS file. And now I would show you how we have to run this file in the Jamovi. So serial number is same, 45, total 45 students marks. Pre-marks, you can see these are the score more than 1 and less more. This one is the, we have assigned 1 and 2, right? And as well as post category, this one is the post training. These marks is also we have defined over here. Suppose you want to see these variables. So once we will do, this is the nominal data. Now we can see 1 means scored more than 50% marks, and scored less than 50% mark, that is 2, right? So we can, this one is, we can see, right, how we have assigned these values, and you can do it, right? You can interchange also, and you can add on one more category. So what we have to do now, we would run analysis. Simply, we will go to analysis, then we will go to, first we have to show you data, then we will go to analyze this data, frequencies. In this frequencies, you can see this option, second last option, not log linear regression. This was the paired sample McNemar test. This option, independent sample chi-square test of association, we had already conducted, and this one is the link I am going to share in this video also. Contingency tables, because this test paired sample t-test on the basis of this one is the tabular basis. And now what we have to do, pre rows, post columns, right? We have to do pre-marks, those before workshop conducted. These are the pre-marks we have taken in the rows, and otherwise a post, those are the this one is the we had conducted once workshop finished. Then after that, whatever is the marks we had scored, this one is the post, and we had conducted this. So now we can see scored more than 50% marks, and those are the scored more than 50% marks. Then when the workshop was not conducted, and this is the post results, scored more than 50% marks in the both the categories, pre and post. So these are the 23. But those are pre-conducted workshop scored more than 50% marks, but post scored less than 50%. These are zero numbers, so total is 23. But those are the scored less than 50% marks, but after conduction of this workshop, total 9 number of people, those are scored more than 50% marks, and 13 people, those have scored less than 50% marks. So this is the total number is 45. So McNemar test, now I just copy this file and I would paste it here. Then we can compare both the results, and let me paste it here. Now we can see, let me come down, and this test also. This is the SPSS results, and these are my McNemar test through Jamovi. And we can see p-value is 0.003, and total number of the cases are 45, and degree of freedom is 1. So here is, we can see row wise, this one is the, and percentage also we can see, right? And column wise also we can see. So all these results are reflected here, percentage within row, percentage within column. Now you can see total number of cases are visible over here. Those have scored more than 50% marks are 23, bifurcation of these 45 marks. Those have scored less than 50% marks, these are 22 students. And p-value, that is same. So I hope that is clear to you, how we have to reject null hypothesis, how we are going to accept null hypothesis. So on the basis of this p-value, we can take our decision, and we have to interpret this data. So I hope this video would be helpful to you, and stay tuned and keep watching.